Hi there. Recall that in the previous video, we learned about the vertex form of a parabola. This is given by the quantity x minus h squared equals 4p times quantity y minus k, wherein p is the focal distance and hk is the vertex of the parabola. But take note that this only applies for parabolas oriented vertically. How about if the parabola is oriented horizontally? Or that is, the parabola is of this form. What is its equation? Well, let's find out what it is in this video, starting with a table comparing vertical and horizontal parabolas. So first, we know that a vertical parabola is of this form. Either it's opening upward or opening downward. So opening upward, when we say opening upward, it's like starting in here, it goes up. And opening downward, it's like starting out here, it goes down. So these two are vertical since it's oriented either up or down only. For horizontal parabolas, these are parabolas of the form this. Either it opens to the right or opens to the left. So similar to this one, opens to the right, like starting out here, goes in here, and starting from the left, goes out here. And it is oriented horizontally since it is only either to the left or either to the right, not up and down. Now, from earlier, we know that the equation of a vertical parabola is of this form. So how about if it is oriented horizontally? How do we obtain that? Well, one way is to derive it like how we did in the last video, wherein we plotted some points out here, some arbitrary points, etc. But that would be problematic and tiring. So one way to obtain its equation is try to analyze and observe how we can obtain this one from this. So let's try to put a graph out here. And our goal is to convert this parabola into this one. Or that is, we'll rotate it by 90 degrees. So by observation, take note that this part out here represents a certain x value out here, say negative x and x out, or just let's use a different letter, negative a and positive a, like that. In here, if we try to convert that, then this part out here would represent a, and this would be representing negative a. Observe that negative a and a out here are on the x-axis, while negative a and a out here are on the y-axis. So it's like moving the x to the y, or replacing x with y out here. And indeed, that's actually the thing that we need. What we do to get the horizontal form of the equation of parabola is just to interchange the y part out here with the x. That is, we'll have this equation. So essentially, it's like the square part is now on the variable y instead of the x. Since in here, the square part is on the variable x. So that is the idea on the equation of a parabola for horizontal parabolas. So again, take note of that one. If the x variable contains the square, it's vertical. If the y variable contains the square, it's horizontal. So that is the first thing that we'll check in dealing with the orientation of a parabola. Aside from this, we can even dive deeper in it. A good question to ask is that if it is vertically oriented, when does it open upward and when does it open downward? Well, the answer to that is it opens upward if p is greater than 0 or positive, and it opens downward if p is less than 0 or negative. So to understand this, observe that if p is positive, then y out here is also positive. So we're dealing with the positive y-axis. If p is negative, then y out here is also negative. So we're dealing with the negative y-axis. So that is the idea in this one. And that is similar for this next example, or this next set of parabolas. For horizontal parabolas, it opens to the right if p is greater than 0, since we are dealing with the positive x-axis. And it is opening to the left if p is less than 0 or negative, since we are dealing with the negative x-axis. So these are the orientation for the parabolas. You may take a screenshot of this one for your reference later on the examples, and as well as for your personal needs. Okay, good. So let us start with some examples. In here, we are tasked to determine the orientation of the parabolas. So we have this first equation and this second equation. Before we start, feel free to pause the video so that you may try this one on your own. Okay, good. So let's start. So let us determine the orientation of these equations. Again, if you didn't take note of the equations, the form of the vertical and the horizontal parabola, you may refer back to that. Just move the timestamp towards there. But if not, here's how we do it. So first, take note. So this is the step 1. Take note where the square is located in the example. Is it on the x variable or on the y variable? Clearly, it is on the x variable. So this means that if the square is located on the x variable, then we know that this parabola is vertically oriented. So that is step 1. Check the square. Step 2. We determine if it is opening upward or downward. And what we use is this one out here. We check if this is positive or negative. Take note that clearly 4 is positive. And when it is positive, this means that the equation or the parabola is opening upward. So we have a vertically, or a parabola that is vertically oriented and opening upward. Just take note that we were able to do that since this equation out here is already in its vertex form. So if not, you still need to manipulate it, then proceed with this 2 steps out here. So again, we have a vertical and upward parabola. And indeed, if we check out its graph, you can clearly see that this parabola is vertical and opening upward. Let's move on to the next example. In here, take note that this one is also already in its vertex form. Just take note that we can write this as x minus negative 1 squared to clearly see that this one is in its vertex form. So again, we first check with the square. Clearly, it is located on the x variable. So similar to the first one, this one is vertically oriented. Aside from that, we check this one. Since this one is negative, then we know that the parabola is, aside from vertical, it opens downward. So this parabola out here is vertical and downward. And indeed, if we check out this graph, we'll have this. So as you can see, this is a parabola that is vertically oriented and opening downward. So these are the answers for this first set of examples. So I hope you got that one correctly. And now let's move on to the next set of examples. Again, we are tasked to determine the orientation of the parabolas. Before we start, feel free to pause the video so that you may try this one first on your own. Okay, good. So let us start. Again, step 1, we check the square. Is it located on the y or on the x variable? In this one, it is clearly located on the y variable. So, if it is located on the y variable, take note that this means that the parabola is oriented horizontally. Next, we check the constant beside the x variable. Is it positive or negative? Well, clearly 6 is a positive number. This means that aside from it being horizontally oriented, it also opens to the right. So we have a parabola that is horizontal and opens to the right. Indeed, if we check out its graph, we can clearly see that this is a parabola that is horizontally oriented and opens to the right. Let's now move on to the last example. In here, take note that this isn't actually in its vertex form yet. Or it is, but it's kind of not clear. So take note that this one is equal to y minus 0 squared equals negative times x minus 5. Now this looks more like the vertex form that we know. So let's try to inspect this instead. First, where is the square located? Is it on the y variable or on the x variable? Clearly, it is on the y variable. So this parabola must be horizontally oriented. After that, we check this part out here. Is this positive or negative? Clearly, this negative out here, so this one represents negative 1, which we know to be negative, so it's less than 0. So this one must open to the left. So combining these two results, we know that this equation of parabola is oriented horizontally and opens to the left. Indeed, if we check out its graph, we have this. So we have a parabola that is clearly horizontally oriented and opens to the left. So I hope you got that one correctly, and yeah, the key is again, first step, check the square. Where is it located? Then check this part out here. Is it greater than 0 or less than 0? So to formally end this, here are some exercises that you can work on. So this is similar to our examples, but take note here that I kind of manipulated the form. So you still need to make this on its vertex form, since it's not quite there yet. Except this one. This one is clearly in its vertex form, but the other ones, you still need to do some trick and some additional step to make it in its vertex form. From there, you can now easily obtain the orientation of the parabola by checking the square, where is it located, and then checking the focal distance, is it positive or negative. So yeah, that's it. I hope you enjoyed and learned a lot from this one. Feel free to comment down below if you have any comments, suggestions regarding this video, as well as if you have an answer to these set of exercises. So yeah, that's it, and that is all for this video.